Have you ever wondered what the universe is made of? Most people think of atoms, energy, or maybe even starlight. But what if I told you that the deepest, most fundamental layer of reality is something else entirely? Something you learned in school, and maybe even disliked. I'm talking about mathematics. Math isn't just a subject, it's the invisible architecture that holds everything together. From the graceful orbits of planets, to the way your smartphone connects to the internet, from the global economy, to the very code of life, everything runs on mathematical principles. In this video, we're going to explore mathematics from the ground up, in a simple, logical way, to show you why it's the most essential language you'll ever learn. So, where did it all begin? Mathematics started with a simple, primal human need. The need to count. Early humans needed to know how many animals were in their herd, how many days had passed, or how much food was left. This gave birth to the natural numbers. 1, 2, 3. These weren't abstract ideas. They were tied to real, tangible things you could see and touch. From there, the four basic operations emerged: addition, subtraction, multiplication, and division. Don't think of these as just rules you memorize. They are actions that organize reality itself. Addition combines things. Subtraction separates them. Multiplication is a form of accelerated addition, and division is the act of fair distribution. Without these four simple operations, there would be no trade, no construction, no planning for the future. Society as we know it would be impossible. As societies grew more complex, so did their mathematical needs. This led to the invention of algebra. Algebra is the art of working with unknowns. The letters you see in equations, like x or y, aren't just random letters. They are placeholders for quantities we don't know yet. Algebra gives us a powerful method to find the unknown by using what we already know. An equation is essentially a statement of balance. It says that two things are equal, even if they look different. When you solve an equation, you're not doing some abstract magic. You are simply restoring that balance to reveal the hidden value. It's like being a detective, following clues to uncover the truth. The next giant leap was geometry. If algebra deals with unknown quantities, geometry deals with space. It describes the world around us through points, lines, angles, circles, and shapes. Look around you. The building you're in, the roads you drive on, the bridges you cross, they all exist and stand firm because of geometry. It's the science of stability, proportion, and form. Without it, our physical world would be a chaotic, unstable mess. Then comes trigonometry, which studies the relationships between the angles and sides of triangles. This might sound specific, but it's the key that unlocked navigation, aviation, and even space exploration. How does a ship find its way across a vast ocean? How does a plane navigate through the sky? How does a satellite stay in its precise orbit thousands of miles above Earth? The answer to all of these is trigonometry. Every time you use GPS, you're relying on calculations that are fundamentally true. But mathematics didn't stop there. For centuries, math was great at describing things that were static. But what about things that change? To understand motion, growth, and transformation, two of the greatest minds in history, Newton and Leibniz, independently developed calculus. Calculus is the mathematics of change. It allows us to describe and predict things like speed, acceleration, the flow of liquids, and the growth of populations. Without calculus, we couldn't model the trajectory of a rocket, understand how financial markets behave, or design efficient power grids. It's the tool that allows us to understand a world in constant motion. But what about the things we can't know for sure? The world is full of uncertainty. This is where probability and statistics come in. They are the mathematics of chance and data. They don't predict the future with absolute certainty, but they give us the best possible guess based on the available information. From the weather forecast you check every morning to the development of new medicines and the algorithms that power artificial intelligence. Everything that deals with uncertainty relies on probability and statistics. They help us find patterns and randomness and make informed decisions in a world of incomplete knowledge. In our modern world, mathematics is the absolute backbone of technology. Your computer, your phone, the entire internet, it all operates on a surprisingly simple system called binary logic. It's a language made of just two symbols, 0 and 1, off and on. This extreme simplicity is what allows for the incredible complexity we see today. Every app you use, every website you visit, every social media feed you scroll through exists because of a complex series of mathematical algorithms. Digital music, high-definition video, online security, it's all math. The digital revolution is, at its core, a mathematical revolution. What's perhaps most mind-blowing is that mathematics isn't just a human invention. It seems to be a fundamental feature of the universe itself. Nature follows mathematical rules. The elegant spiral of a seashell, the branching pattern of a tree, the hexagonal cells of a honeycomb, and even the majestic spiral arms of a galaxia, of these can be described by precise mathematical structures like the Fibonacci sequence or fractals. This strongly suggests that we didn't invent math, we discovered it. It's a pre-existing language that describes the cosmos, and we are just slowly learning how to speak it. So, in the end, math is not about complicated formulas or passing difficult exams. It's about something much grander, understanding the very fabric of reality. It's the language that reveals the hidden order within chaos and the beautiful structure within apparent randomness. It's the story of how everything is connected. If this video helped you see mathematics in a new light, please give it a like and subscribe to the channel. By doing so, you help this educational content reach more people who might be curious about the secret language of our universe. Thanks for watching.